Younger, I've always been passionate about computer graphics and land generation. How games like The Binding of Isaac, Terraria, Starbound, Minecraft or even Skyrim can provide such a variety of environments. Obviously, it's not made by the hand of a human, but by algorithms. These algorithms that can generate an infinite number of rooms, houses, villages, mountains, and worlds belong to the realm of procedural generation. I wanted a fun project, quite simple, that I would spend a few hours on, get satisfied with the result, and move back to work. Spoiler, this was not the case. I chose Python because I wanted to keep the possibility to use NumPy and SciPy, some mathematic signal processing libraries, to spice up the result in case I would have some more spare time. Unfortunately, this will be for another video. I started by having a look to the Minecraft file format. The NBT files are basically dictionaries of dictionaries of dictionaries of, well, you get the idea. They are written in a binary format for parsing and storage efficiency. On top of the NBT standard, you have the Anvil file format, which is specific to the Minecraft maps. I searched for a library that would do the parsing for me. I knew that NBT had plenty of implementation, but it seems that the Anvil format had only one in Python, written on top of the Python NBT library. After reading documentation and some code example, I gave it a try. Not bad. Good start. To make things more interesting, I need some random input. A very commonly used algorithm in parametric texture and line generation is the purely noise. The purely noise is basically an optimized algorithm that generates some noise on the corner of a grid and smooths the intermediate value between them. This gives smooth transition between height, altitude and low altitude points on a map. Okay, this is not very smooth. Let's try again. Look at these nice curves. Gorgeous. We can also flatten a little bit the shapes. Perfect. The next step was to experiment with different materials. Unfortunately, using this framework and experimenting wasn't going as I expected. It was very slow and ordering of the cube was a bit confusing. I tried different noise library as the OpenSimplex Python implementation was way too slow. I settled on a purely noise library that I would later replace by a faster and multi-threaded library named PyFastNoise SIMD. I was still confused with the region/chunk/section structure of files. First, the map is divided of region measuring 512 times 512 blocks. Then a region is divided into chunks 60 times 266 times 16 blocks, and each chunk is sliced vertically into sections of 16 blocks. It took me some time to figure it out, but I finally managed to write the block I wanted where I wanted. The next step was to cut the shape of my island using a threshold on the purely noise mixed with a small gradient to ensure the top of my island will remain almost flat. Then I started playing Russian dolls by putting different materials inside and outside the island, kinda like the yellow part and the white part of an egg. I had a look at the different blocks available from the Minecraft wiki and started experimenting. Who wants a pumpkin island? So I started to mix ground and andesit on the outside of an island. Well, let me fix it. Okay, after a couple of hours, I finally got the ground on top, the rocks inside, and the andesit as a shell. It was a bit tricky, and playing with indexes and NumPy tensor was not that easy, but I managed to get the expected result. The next step was to... add ore inside the heart of island, like chocolate chip in a cake. To model the chocolate chip, I used the Poisson process. And because I perfectly remembered how Poisson process works, I was able to implement it without even reading any documentation or testing it in the Python interpreter. Okay, you caught me. I didn't know much than the name at first. After some time, I felt like fish in water, with this probability distribution and got some nice result. OMG. It is so beautiful. Let me scratch a little bit the surface. I had to tune the quantity of different ore in order to balance a little bit the game. Mixing Poisson distribution for localization of seed, a percolation process for growing ore in the rocks, and by adjusting the parameters, I got the perfect result. Now it's time to grow some trees. I used again a Poisson process to locate the trunk of my trees, but this time only on the surface of the island. By combining with appellant noise and threshold, I was able to make the tree more sparse and have both forest and land. After some work, I got the trunk built. Finally, the final touch, the leaves. I also added some flowers and grass just to make the whole island look nicer. At this point, most of the necessary resources are available. The only key remaining things are water and lava. Indeed, you need lava to create obsidian and enter the nether. At first, I just created water and lava pool, choosing the localization with a Poisson process, again, and controlling their size with percolation process, again. Unfortunately, lava burned, so I added some rock around the border to make sure it won't burn the trees that are growing next to it. So guys, thank you for staying with me so far. I shared the code on GitHub with you if you want to have a look and play with it. Maybe you can replace the lava by pumpkin and turn some tree into diamonds or whatever. It was very interesting for me to touch a bit of a procedural world generation algorithm, and it's definitely something I will give it a try again in the future. Please let me know your thoughts about this video. Did you enjoy it? Do you want more similar content? Let me know if you also tried generating programmatically environment, or if you would like to experiment with it in the near future. I hope you had fun watching, and we'll see you in the next video. And don't forget to subscribe to receive the notifications.